Dear students, in this lecture we are going to discuss about retarders, or the other name is wave plates. Quarter wave plate and half wave plate are commonly used retarders. It is usually made up of quartz crystals. Here a certain optical element that is used to change the state of the polarization of the incident light. They are called retarders. That is, here there is a change of the state of the polarization of the incident light. When a polarized light, when a polarized light, not the unpolarized light, when a polarized light that is incident on retarders, what happens? It is split into two plane polarized light. That is, one is ordinary ray and another is extraordinary ray. The important point is that both these ray, they are travels along the same direction, but one of them lags behind the other by a definite amount. So the name is retarders. One of them lags behind the other. When ordinary ray may be lagged behind extraordinary ray, or extraordinary ray lag behind the ordinary ray. That is based upon the property of the crystals. That is, usually these retarders made up of the quartz crystals or the splits of the mica crystals. And on emerging from the retarders, what happens? These two waves, that is, one ray that is lags behind the other, these two rays superimpose each other to produce a wave which has a state of polarization that is entirely different from the incident light. Quarter wave plate and half wave plate, they are also called retardation plates, as they retard either ordinary ray or extraordinary waves. Now we are going to see the difference between the quarter wave plate and half wave plate. Quarter wave plate is also known as lambda by 4 plates, and half wave plate is also known as lambda by 2 plates. Here, see, a plate of doubly refracting uniaxial crystals that is cut in such a way that cut with its refracting faces parallel to the optic axis, that is capable of producing path difference of lambda by 4 between the ordinary ray and extraordinary waves. But here plate is cut with its refracting face parallel to the optic axis, that is capable of producing path difference of lambda by 2 between the ordinary waves and extraordinary waves. That is, if a plane polarized light of wavelength lambda falls normally on such a plate, that is, either it is quarter wave plate or half wave plate, inside the plate it is split into two waves, ordinary waves and extraordinary waves. Both these waves travel in the same direction but with different velocity. See this point. These two waves travels in the same direction but with different velocity. If we take the negative crystals, that is calcium crystals, the velocity of the extraordinary ray that is greater than that of the ordinary ray. So it is obvious that refractive index for the ordinary ray that is greater than the extraordinary ray. Let T be the thickness of the plate. This T be the thickness of the plate. Suppose this is the plate. So this is T. This T is the plate, that is geometrical path. Then what about the optical path for the ordinary ray? That is n0t, that is n0 into t. Then then about the extraordinary, that is optical path for the extraordinary ray, that is ne into t, product of the refractive index of the extraordinary ray into its geometrical path. Then only we can get the optical path. Now it is easy to find out the path difference between these two rays. Just take the difference, n0t minus net. We will get the path difference delta. And then just go to the definition. When this path difference, that is equal to lambda by 4, we will get quarter wave plate. And when this path difference, that is equal to lambda by 2, we will get half wave plate. We will see the path difference, no minus ne into t, that is the optical path difference. T is the geometrical path difference. When this path difference equal to lambda by 4, we will get quarter wave plate. We will do just simple mathematical steps. No minus net, that is equal to lambda by 4. We will get t is equal to lambda by 4 into no minus ne. That is for the case of the negative crystals. If we have take the positive crystals, just like quartz crystals, the thickness of the glass plate, t is equal to lambda by 4 into ne minus no. See the difference here. In the case of the half wave plate, this path difference, that is equal to lambda by 2, no minus ne into t, that is equal to lambda by 2, t is equal to lambda by 2 into no minus ne, that is for the negative crystals. And for the positive crystal, t is equal to lambda by 2 into ne minus no. By using the quarter wave plate, we can easily produce elliptical or circularly polarized light. Circularly polarized light, that is one of the special case of the elliptically polarized light. By using the half wave plate, we can produce plane polarized light. And from these two equations for the thickness of the glass plate, we can see that, or we can understood that this thickness depends upon the wavelength lambda. That is, a particular plate can be accurately used with only with one wavelength. That is, here the thickness depends upon lambda. So only we have used a particular plate can be used only for particular lambda. So the same plate cannot be equally suitable. The same plate will not equally suitable for other wavelengths. If we will take this 532 wavelength, we will cut the plate up to based upon that only particular wavelength. Now if we move to change to this wavelength 532 to 630, what happens? We need to find out the value of t. So the t is depends only a particular wavelength. It will not equally suitable for other wavelength. So this is the one of the major disadvantage of this quarter plate. That is, depending upon the wavelength, we need to design, or we need to create wave plate. Okay. So elliptically polarized light we can generate by using the quarter wave plate, and plane polarized light we can produce the plane polarized light using the half wave plate. When the path difference, that is equal to lambda by 4, we will get quarter wave plate, and when the path difference that is equal to lambda by 2, we will get halfway plate. And also note that phase difference and the path difference, they are connected. That is phase difference, that is equal to 2 pi by lambda into path difference, that is phase difference, that is lambda by 4. The path difference, that is equal to lambda by 4. The phase difference is pi by 2. Then what about the path difference, that is equal to lambda by 2. The phase difference, that is pi. Just note these points. Thank you.